Question number 28. A 385 centimetre cube sample of carbon dioxide. I've got the pressure in kilopascals and I've got a temperature. Was then mixed with argon. I've got a gas constant. So I'm looking at PV equals nRT. And I've been given information about the carbon dioxide. I can work out number of moles of carbon dioxide. Then it's told me the number of moles of argon that I'm mixed with. That's the next stage. So what the mole fraction is, it's the number of moles of carbon dioxide as a fraction of the total number of moles. So my first step is to work out the number of moles of carbon dioxide using PV equals nRT. The R gives me a clue that I'm going to be using PV equals nRT. Let me do spoilers because I've got centimetres cubed here, kilopascals and 25 degrees C, and they're all wrong. This needs to be in meters cubed, this needs to be in pascals, and this needs to be in Kelvin. So let me show you what I'm doing. I'm taking for carbon dioxide, so for kilopascals into pascals, that's a larger unit than this unit, so I'm going from large unit down to small unit, so I multiply by 1,000 to get small units, large units into small units. 100 kilopascals is 100,000 pascals. Volume 385 centimetre cubed. So to get it up into decimetre cubed, up into a larger unit, I divide by 1,000, so that would be 0.385 decimetre cubed. And then to go up into another larger unit, meters cubed, from decimetre cubed, I divide by 1,000 again, so 0.000385 meters cubed. 25 degrees C into Kelvin, I add on 273, so 273 add 25 is 298 Kelvin. Now I've got all of those in the right units, pascals, meters cubed and Kelvin. PV equals nRT, so pressure multiplied by volume is 100,000 pascals multiplied by volume 0.000385 equals the number of moles, that's what I want to find, multiplied by the gas constant, which I'm always given, 8.31, multiplied by 298. I would always multiply these out first on my calculator so that you don't make mistakes. So 100,000 multiplied by 0.00385 is 38.5, and these two multiplied together, 8.31 times 298 is 2476.38. Now I do n is 38.5 divided by 2476.38, 0.0155. That's the number of moles of carbon dioxide because I've used the data for carbon dioxide. The total moles of gas then, all the moles of gas then together, including the 2.89 times 10 to the minus 2 moles of argon, I add together. So I add the number of moles of carbon dioxide and the number of moles of argon, 0.0444. That's the total number of moles of gas. So my mole fraction of carbon monoxide is the number of moles of carbon monoxide that I have, divided by the total number of moles of gas that I have altogether in the mixture. So 0.155, the number of moles of carbon dioxide that I have, divided by the total number of moles of gas in the mixture. 0.0444 is 0.35, so my answer is A. 29. How many peaks does this compound have in its carbon-13 spectrum? So I'm looking for the number of different carbon environments. That S isn't in the middle. If it were here, it would be different, but it's not. It's not symmetrical in any way. So all of these carbons are going to be in different environments because that S is not forming a symmetrical structure. So I've got 1, 2, 3, 4, 5, 6, 7, 8 different carbon environments, because that S is not forming a symmetrical structure in any way. The answer is D. 30. A student is provided with 5 centimetre cubed of 1 mole per decimetre cubed ammonia solution. So without looking any further, I've got a volume and I've got a concentration. I can work out moles of ammonia. So let's do that now. 5 centimetre cubed up into decimetre cubed, I divide by 1,000. So that's 0.005 decimetre cubed of 1 mole concentration. So concentration is moles divided by volume. 1 equals moles divided by 0.005 decimetre cubed. The number of moles of ammonia is 0.005 decimetre cubed. Let's read on through the question now. The student was asked to prepare an ammonia solution of concentration 0.050 using this solution. So I know that the number of moles hasn't changed, but the amount of water has changed. So in the new solution, the new concentration is 0.05. 0.05 is the number of moles. Well, I'm using this ammonia solution. I'm not changing the number of moles, I'm just changing the amount of water. So 0.05 is 0.005 moles divided by volume. Volume, therefore, is 0.005 divided by 0.5, 0.1 decimeter cubed, which is 100 centimeter cubed. So to get decimeter cubed into centimeter cubed, and all these are in centimeter cubed, I have to multiply by 1,000 to get decimeter cubed, a large unit value, into a smaller unit value like decimeter cubed. I multiply by 1,000. 0.1 multiplied by 1,000, 100 centimeter cubed. Now, you may be tempted just to go for C, but read the question carefully. What volume of water should the student add? You had 5 centimeter cubed originally. You now want it to be 100 centimeter cubed, so you need to add a further 95 centimeter cubed. The answer is B.